Beneath the waves, far from sunlight and human reach, lies a world that defies the rules of life as we know them. Sailors have long told stories of sea monsters, creatures too large and bizarre to believe. While we haven't discovered tentacled leviathans pulling ships into watery graves, what scientists have found in the deep sea is equally astounding. The deeper we dive, the bigger, stranger, and more mysterious the creatures become. This curious phenomenon is called deep-sea gigantism, and it reveals a lot about how life survives in the most extreme environments on Earth. But how do animals in the ocean's deepest parts grow so large? The answer lies in the cold, dark depths, and in evolutionary rules that are both fascinating and complex. You'd think the crushing pressure of the deep sea would make creatures smaller, not bigger. After all, down there the pressure is so intense it would flatten a human in seconds. But for animals made mostly of water, pressure isn't much of an issue. These creatures drift freely, their buoyancy allowing them to grow with little resistance from gravity. This freedom gives rise to creatures larger than anything we find in shallower waters. Still, understanding how they grow is only half the mystery. To explain why they become giants, scientists turn to two biological principles: Kleiber's rule and Bergmann's rule. According to Kleiber's rule, larger animals are more energy efficient. Think of a whale compared to a small fish. Because whales have a lower surface area to volume ratio, they lose less heat, allowing them to conserve energy better. For deep-sea animals where food is scarce, this energy efficiency can mean the difference between survival and starvation. Then there's Bergmann's rule, which tells us that animals tend to grow larger in colder environments. In frigid waters, a slower metabolism extends their lifespan, giving creatures more time to grow. The deep ocean, with its freezing temperatures and oxygen-rich currents, provides the perfect conditions for this phenomenon. This is why many of the giants of the deep grow slowly, often moving through life at what seems like half speed. Now, let's meet some of the ocean's most extraordinary residents. The colossal squid is perhaps the most famous example of deep-sea gigantism. This massive predator can reach up to 15 meters, 49 feet, in length and weigh around 700 kilograms, 1,500 pounds. Living more than 2,100 meters, 1.3 miles below the surface, the colossal squid has enormous eyes to navigate the pitch-black waters and tentacles lined with sharp hooks to capture prey. Another example is the giant isopod, a deep-sea relative of the common pill bug. While most isopods are only a few inches long, giant isopods living in the cold waters of the Pacific, Atlantic, and Arctic Oceans can grow to over half a meter, 20 inches, and weigh nearly 2 kilograms, 4 pounds. These eerie crustaceans slowly scour the seafloor, surviving on whatever organic material drifts down from above. Their large size helps them endure long periods without food and travel great distances in search of their next meal. Even stranger are the massive sea spiders found near the poles, some of which grow to the size of dinner plates. In these cold, oxygen-rich waters, their metabolisms run so slowly that they seem to move in slow motion, living much longer than their warmer water relatives. Their size and alien appearance make them look more like creatures from another world than life forms from Earth's oceans. The deep ocean works a bit like an isolated island. On land, animals living on islands often evolve to unusual sizes, either much larger or much smaller than their mainland relatives. This is known as the island rule. A perfect example of this is the Galapagos tortoise, which grew to enormous sizes in isolation due to the lack of predators and limited resources. Similarly, the creatures of the deep ocean evolved in isolation after the Cenozoic extinction event more than 65 million years ago. Shallow water animals ventured into deeper waters and over millions of years transformed into the giants of the abyss. This evolutionary isolation allowed many species to diversify and adapt in ways that would be impossible closer to the surface. Gastropods, a group that includes snails and slugs, provide a striking example. In shallow waters, these creatures are usually small and unremarkable. But in the deep, some gastropod species grow to enormous sizes, proving that evolution in the abyss follows its own unique rules. Despite their impressive adaptations, these giants now face a new threat: climate change. As global temperatures rise, the oceans are slowly warming, even at their deepest levels. This change could disrupt the delicate balance of temperature, oxygen levels, and food availability that these creatures rely on to survive. Warmer waters mean less oxygen, which could interfere with the slow metabolisms that allow deep-sea animals to grow so large. If the ocean giants cannot adapt to these rapid changes, they could face extinction. This would not only be a tragic loss for biodiversity, but would also leave us with many unanswered questions about how life thrives in one of the most extreme environments on Earth. The colossal squid, giant isopods, and other massive creatures may be among the first casualties of a changing ocean, silent victims in a world few of us ever get to see. Deep-sea gigantism is one of the most fascinating examples of evolution's ability to push life to its limits. In the cold, dark depths of the ocean, creatures have grown large not by accident but by necessity. Adapting to a world where food is scarce, temperatures are low, and survival requires extreme efficiency. These giants remind us that even in places beyond human reach, life finds a way to flourish. But as our planet warms, the future of these magnificent creatures hangs in the balance. Will they adapt to the changing conditions? Or will they disappear, taking their secrets with them? The ocean's depths are still a mystery, filled with creatures we can barely begin to understand. And the deeper we dive, the more we realize that in the abyss, bigger is better, for now. If you enjoyed this journey into the ocean's mysteries like this video, share it with other curious minds and subscribe for more deep-sea explorations. Hit the bell icon so you never miss an upload. See you next time, explorers.